Hello! Welcome to another edition of Simple Debugging Tips for your microcontroller. In this video, I'm going to show you how to interact with your microcontroller using a USB to serial adapter and a terminal application. Here we won't need an expensive debugger software or an expensive oscilloscope. We will use the HyperSerialPort terminal software and the VisiPort USB to serial adapter. The VisiPort is a USB to serial adapter board. It converts the USB signaling into serial UART signals. When the VisiPort driver is loaded onto a Windows machine, it acts just like a COM port. Using the HyperSerialPort terminal application, you can set the baud rate, number of data bits, flow control, and anything else you can do with a built-in COM port. The VisiPort has a top baud rate of 3 megabaud. To keep the board small, the VisiPort uses a USB mini-B connector. When we flip the board over, we can see the FTDI FT232R chip. The UART signals RxD and TxD are broken out to 100mm header pins that are easily accessible by connecting wires to these pins. The ground and general purpose I/O pins are also accessible on the 100mm header pins. The VisiPort is powered from the USB cable, so to turn it on, just plug in the USB mini-B cable, follow the instructions in the user manual to load the Windows driver, and it's ready to use. The USB conversion to UART signals is transparent to the user. The FT232 chip takes care of this conversion. The VisiPort UART pins will connect to the microcontroller UART pins. This allows you to send and receive characters from the HyperSerialPort terminal and talk directly to the microcontroller. We will add a smart core to the code of the microcontroller. This will allow us to use this dumb terminal to probe the internal workings of our microcontroller code. So, let's walk through a project where we utilize this smart core. I've created the Zigbee emulator project so that I can test out the interaction between my microcontroller and a Zigbee radio. The HyperSerialPort terminal will talk directly to the smart core inside the microcontroller code using the VisiPort, and the microcontroller will talk to the Zigbee emulator across the SPI bus. The equipment that will be needed for this project is the MSP430 microcontroller, an Uno ProLogic CPLD board, a VisiPort USB to serial board, an MSP430 programmer cable, and snug jumper leads. The Zigbee emulator development process included using two off-the-shelf boards. I used an Olimex MSP430 board for my microcontroller, and I used the Uno ProLogic board to emulate the Zigbee chip functionality. I connected the two boards together using snug leads between their male headers. Next, I purchased a JTAG programming cable for the MSP430. Connect this from the PC to the MSP430. This cable provides the firmware download and step debugging for the MSP430. Finally, connect the VisiPort to the microcontroller to provide communication between the PC and the microcontroller. I used the IAR embedded workbench to write, compile, and debug my firmware. The IAR software has a free version, but is code size limited to 4K. To utilize the peripherals of the MSP430, I call the initialization functions GPIO, SPI, UART, and the interrupt functions. After initialization, the code calls the user application function. In this user app function is an infinite loop using a while1 statement. This loop will constantly call the debug menu function. And this is where the magic happens. It is where the smart core of the microcontroller code is. This function provides a user console in which to send commands and receive responses from HyperSerialPort. Using the debug menu, we can monitor all of the interaction to and from the Zigbee emulator. For the microcontroller to communicate with the built-in serial port, I'll add several functions that will handle writing the characters and strings out of the serial port. I've set up an interrupt handler to alert the microcontroller code when the serial port has received a character from the hyperserial port. So here you can see I've added several functions which will maintain communication between the microcontroller and the ZigBee. These functions include a method to assemble the command bytes, a send when ready method, and CRC checking. So the debug menu uses multiple levels of menus to allow the user to select the appropriate function to execute. These multi-level menus use a top-level function to default to. This top-level menu is displayed the first time through the debug menu function. Below this top level is the rest of the sub-menus. The user can write as many sub-menus as the project needs. Just select a menu by typing the appropriate character into a hyperserial port. To communicate over the ZigBee emulator, select a ZigBee function from the sub-menu. To do this will cause the MSP430 to send a command to the UnoPro logic over the SPI bus. The UnoPro logic will then execute some code and send a response back to the MSP430 over the SPI. When the code is entered and ready, I click on the Make button and the project goes to the compile link processor. After this is complete, I click on the Download button and this downloads the compiled code to the flash and starts execution at the first instruction. So now we're ready to see this in action. Let's open up the hyperserial port application. Click on the Properties button, go to the combo box and select the COM port where the VisiPort is located. Make sure the bits per second box shows the baud rate of the MSP430. In our case this is 9600. Go to Flow Control and select None. Next click on the Connect button and hyperserial port is ready to use. So in the hyperserial port application, the window will display the characters from the MSP430. Here you can see the Debug Console top menu. There's a couple of menu options to choose from. To select ZigBee Network command, I enter a 1 from the keyboard to access the sub-menu. When it comes up, I can select from 7 different commands to send to the ZigBee emulator. I will select the Initialize ZigBee by entering 1 from the keyboard. Here you can see the Initialize ZigBee command that was sent to the emulator, the ZigBee emulator. The MSP430 sends a command consisting of a string of hex numbers. The ZigBee emulator receives these numbers and sends back a response message consisting of a string of hex numbers. These values are then displayed in the terminal window. Choose any menu command by entering its character into hyperserial port. Here you can add your own code to return information about what's going on inside the microcontroller code. Because the debug console is called once per cycle in the user app loop, it won't interfere with any of the functioning in your system. So you can also use hyperserial port to send hex characters. Click on the Send Console button and the console comes up. Here I'm going to enter 31 in the character send box. 31 is the hex number for the ASCII 1 character. Hit send and I get the same response from the ZigBee emulator. I can also repeat the hex number send indefinitely by changing the repeat send box to 0. Hyperserial port will continue to send the 31 character forever. Click on the stop button to stop the repeating send. The most brilliant point about this debug console is that it doesn't interfere or even slow down the execution of your code. Add your code to the user app loop function. Here, I will add a function to scan the ZigBee network and return all of the nodes and coordinators that it sees. Your code will execute once per cycle of this loop. Also, the debug menu function will be entered each cycle. If Hyper Serial Port has sent no characters to the MSP430, it returns after checking the serial port. This only takes a few instructions. So, that is the method to debug your microcontroller code using the inexpensive VisiPort USB to serial adapter and the free Hyper Serial Port terminal application. You can use Hyper Serial Port to initiate processes, stop data transfers, and post the results to the terminal window. All of this without the need for expensive debugging software or an oscilloscope. I have posted all of the source code for the microcontroller, the Uno Pro Logic, and the C# application on the Earth People Technology website. If you have any questions or would like to see any code written for a specific project, please post it in the forum. Thanks for tuning in.